Hello, viewers. Welcome to another episode of Knowledge Sharing. Before we continue, I'd like us to like and follow our Facebook page, subscribe to our YouTube channel, comment, and share our video for more interesting topics. Today, we are looking at this question, and it's given to us by one of our fans, and we want to try something a little bit advanced. The question says, determine the area bounded by the curve r equals to sine theta plus 2 cos theta, and the radius vector theta equals to 0, theta equals to pi all over 2 for theta equals to integral with limit of theta 2 and theta 1 all over 2 r squared d theta. So we need to find the boundary vectors of this theta. We have solution. We are given that r equals to sine theta plus 2 cos theta. So in this case, for our equation here, we have theta equals to integral of theta 2 to theta 1 all over 2 r squared d theta. So in this case, we are told that r equals to sine theta plus 2 cos theta. So we have theta equals to integral of theta 2 theta 1 all over 2. We replace r in the place of sine theta plus 2 cos theta. So this will be sine theta plus 2 cos theta all raised to the power of 2 d theta. So in this case, we have this parenthesis, the square of sine theta plus 2 cos theta. So we need to evaluate this. Evaluating this will become sine theta plus 2 cos theta all sine theta plus 2 cos theta. So we need to expand this. Expanding this will give us sine theta times sine theta will give us sine square theta. Then sine theta plus 2 cos theta will give us plus 2 sine theta cos theta. Then 2 cos theta times sine theta will give us plus 2 sine theta cos theta. Then the next one is 2 cos theta times 2 cos theta will give us plus 4 cos squared theta. So this is what we have for the expansion of this. So this, we know that is the same thing as 1 all over 2 is here into all this. So we have this. So the next thing we are going to do is to collect like terms. And here we have 1 all over 2 into, this is sine square theta. We have sine square theta. Then we have 2 sine theta cos theta plus 2 sine theta cos theta will give us 4 sine theta cos theta. We add this. So now the next one will be plus 4 cos squared theta plus 4 cos squared theta. So that's the end of this. So we close the parenthesis. So now we have this. In trigonometry, we recall that when we have sine squared theta plus cos squared theta equals to 1. So we're making the sine squared theta the subject of this expression. We have sine squared theta equals to 1 minus cos squared theta, because this cos squared theta will be transposed into this other side, will become minus cos squared theta. So what we are going to do here is for us to substitute this sine squared theta into this expression. So we have this as 1 all over 2 into, in the place of sine squared theta, we substitute 1 minus cos squared theta. So we have 1 minus cos squared theta, then we bring down plus 4 sine theta cos theta, then plus 4 cos squared theta. So this is what we get. Then we still remember that we have the limit, the integral. We'll bring it later. So the integral of this limit is still there. In this case, we have to evaluate this for us to eliminate this 4 sine theta cos theta. We can further break this down. So we have 1 all over 2 into 1 minus cos squared theta plus this 4 can also be written 2 raised to the power of 2, which is 2 times 2 sine theta cos theta, then plus 4 cos squared theta. So here, in this case, recall that sine 2 theta equals to 2 sine theta cos theta. So what we are going to do is to substitute this sine 2 theta into where we have this. So we have, this is the same thing as 1 all over 2 into 1 minus cos squared theta plus 2 times 2 sine theta cos theta. So we have that, then plus 4 cos squared theta. So we have, in this expression, we have 2 sine theta cos theta. So the next one is for us to substitute this into this place. So we need to clean this. So we have, as we say, that sine 2 theta equals to 2 sine theta cos theta. So for our expression, we have the integral of the limit of 0 to pi all over 2, 1 all over 2 into 1 minus cos squared theta plus 2 times 2 sine theta cos theta, then plus 4 cos squared theta. So that is what we have. We are transferring this to this other side, so we'll be able to clean this side for us to have space. So we have this. What we are going to do is to substitute this into here. So we have 1 all over 2 into 1 minus cos squared theta plus 2 times, in the place of this, we are going to substitute this, which is times sine 2 theta. Then we bring down this plus 4 cos squared theta. So this is what we have. Then here we have minus cos squared theta here, 4 cos squared theta. So we collect like terms. So that will become 1 all over 2 into 1 plus 2 sine 2 theta. Here, minus cos squared theta, subtract from 4 cos squared theta will give us plus 3 cos squared theta. So this is what we've gotten. So now the next step is for us, okay, we bring down our integral sign, which is the limit of 0 to pi all over 2. So this is what we have for the limit. So the next one now is for us to integrate each of this section of this equation. How do we do that? We need to integrate one after the other. Let's integrate sine 2 theta. This will give us, integrating this, we say let 2 theta equals to u. Then the du d theta will give us 2. Therefore, this will give us d theta equals to du all over 2. Then here, for us to substitute the d theta into this other place, because this place is d theta, substitute d theta into here, we now have integral of sine, because we say 2 theta is u, going to be u times, in the place of d theta here, we put du all over 2. So this is the same thing as 1 all over 2. This is the same thing as the 1 all over 2 will be outside, integral of sine u du. So this is for the sine u. So integrating sine u will give us 1 all over 2 into minus cos u. So this one will be plus c, because for integration you need to add constant. But here this will become, because we say let u become 2 theta. So this will become minus 1 all over 2. Then we have cos 2 theta plus c. So this is what we are going to substitute into here. So this is for sine 2 theta. So we have this other side, cos squared theta. So the next one is for us to integrate cos squared theta. We have integral of cos squared theta d theta. So what we have here, cos squared theta is the same thing as cos squared theta equals to 1 all over into 1 plus cos 2 theta. So what we are going to do is to substitute this into what we have here. It's going to be 1 all over 2 integral of into 1 plus cos 2 theta d theta. So we are going to integrate this. Integrating this will give us 1 all over 2 into theta plus sine 2 theta plus c. So this is what we've got from integrating cos squared theta. So the next one is for us to substitute this into where we have cos squared theta. Having that, we are going to plane this section. So substituting the value of sine 2 theta and cos squared theta, we'll have the integral, the limit of 0 to pi all over 2, bracket 1 all over 2, open parenthesis. Then we have 1 plus 2. Then where we have sine 2 theta, we'll put minus 1 all over 2 cos 2 theta, then plus 3. Where we have cos squared theta, we substitute this into that, we have into 1 all over 2 into theta plus sine 2 theta. So this is the new equation we've got. So we are going to clean this so that we have space. So we clean this and we can rearrange this. We have integral of limit of 0 to pi all over 2 into 1 all over 2 into 1 plus 2 minus 1 all over 2 cos 2 theta plus, then we bring down this one, we have 3 into here. The integral of that cos squared theta is sine 2 theta all over 2. We didn't put all over 2. So next is for us to expand it. When expanding this, we have 1 all over 2 times here. By rearranging, we have 1 all over 2 sine 2 theta all over 2 plus 1 all over 2 times theta. So this is what we've got. So now we have 1 all over 2 here. It can be the same thing. When we move this 2 to this other side, it can be 1 all over 4. 1 all over 4 times sine 2 theta. So in this case, we can factorize this. So we have this, bring down this 0 into 1 all over 2, 1 plus 2 minus 1 all over 2 cos 2 theta plus 3. So in this case, we can make 1 all over 2 to factor this. So it's going to be times 1 all over 2 into 1 all over 2 sine 2 theta plus, because we factor this, is going to be plus theta. So we have that. This is the same thing as this. Let's quickly do this. This 3 times 1 all over 2 is the same thing as 3 all over 2. So we get this. We still have integral here, but we've integrated this. The only thing we've not integrated is this one. So what we need to do is to remove this. We would have removed this. So from here, integrating 1 is theta. Here will be theta. Here will be theta, and here will be theta. So this will move from this other side to this other side. We will have pi all over 2 from 0 to pi all over 2. So we remove all this because we've completely integrated the whole of the bracket. So all this is going to be pi all over 2, 0 to pi all over 2. So this is what we've got. Now, we have fully integrated the whole of the equation. So what we are going to do is to do another expansion and also to substitute the limit from 0 to pi all over 2. So what we are going to do now is to have this will become 1 all over 2 into theta plus 2. This 2 will cancel itself. So this will become minus will come here. So we have minus cos 2 theta plus, here we will expand this. We have 3 all over 2 times 1 all over 2 sine 2 theta plus 3 all over 2 theta, all the limit of 0 to pi all over 2. That is what we've gotten. So this is the equation. So now what we need to clean the upper side now for us to fit in. So we clean this. So this is the equation that we've gotten now. So the next step is for us to substitute the limit from 0 to pi all over 2. So anywhere we see, we take pi all over 2. So where we have theta, we put pi all over 2, then 0. So we have this as 1 all over 2. Open the parentheses, we have theta here. That will be pi all over 2 minus cos 2 pi all over 2. This is where we are. Plus 3 all over 3 plus 3 all over 2 times 1 all over 2 sine 2 pi all over 2. Then here plus 3 all over 2 times pi all over 2. That is for pi all over 2. Then minus for 0, we have for theta here we have 0 minus cos 2 times 0 plus 3 all over 2 times 1 all over 2 sine 2 times 0. Anywhere we have theta, we have put 0 plus 3 all over 2 times 0. Then this is what we are going to evaluate. So we can further simplify this. So we have 1 all over 2 into 3.142 all over 2 minus cos 2 into 3.142 all over 2 plus 3 all over 2 times 1 all over 2 sine 2 into 3.142 all over 2 plus 3 all over 2 times 3.142 all over 2. So that is for the first line. Then the second line, here we have minus 0 minus cos 2 times 0 is cos 0. Cos 0 plus 3 all over 2 times 1 all over 2 sine 2 times 0 is sine 0 plus 3 all over 2 times 0 is 0. So that is what we have. We can further simplify this. This will become 1 all over 2 into 1.571 minus cos, here 2 will cancel here, 2 will cancel here. It's going to be cos 3.142 plus, here will become 3 all over 2 times, this place will be sine 3.142 all over, it will become 1 all over 2 sine 1.571 plus, this will become 3 all over 4 times 3.142 because 2 times 2 is 4. Then we have that. So here for the second line, this will become minus 0. Cos 0 is 1. Cos 0 here is 1. So we have minus 1 plus here sine 0 here is 0. Then 0 times 3 all over 2 is going to be 0. Then plus this 0. We close the parentheses. So the whole of this we have only minus 1. So what we have now is to further simplify this other side. So we have 1 all over 2 into 1.571 minus, we have cos 3.142 is equals to, when you punch our calculator, you have 0.999. So that will give us approximately 1 plus, so we have 3 all over 2 times 1 all over 2 times 1.571. So this will become 3 all over 2 times 1 all over 2 sine 1.571 will give us 0.055. Then plus 3 all over 4 times 3.142. So we have that. We are going to further simplify this other side. So this one, the whole of this, we say that remain minus 1. Here will be minus 1. So minus 1 will become plus. So we have to further simplify this. 1 all over. Simplify this will give us 1 all over 2 into 1.571 minus 1 plus, when we punch our calculator, 3 all over 2 times 1 all over 2 times 0.055. This will give us 0.04125. Then this other one, we have plus 3 all over 4 times 3.142. This will give us 2.3565. Then minus 1 will become plus 1. Then here, we punch our calculator. The whole of this will be 1 all over 2 times 3.96875. This will become 3.96875 all over 2 will give us 1.98445. The unit in square unit. So this is the answer of what the limit from 0 to theta all over 2 with the equation that they've given from the question. This is what we've got, 1.98445 square unit. If you like what we are doing here, follow us on our Facebook page, subscribe to our YouTube channel, comment and share our video for more interesting topics. Thank you.